Okay, so here we have a real-life application of arc length. So I'll read the question to you and then I'll solve it. So Mark drives his car on a circular path. Mark starts at point A and stops at point B. The circular path has a radius of 15 meters and Mark created a central angle of 3 radians. What is the distance Mark traveled in his car? Okay, so I drew a diagram here that shows what's going on here. But before I explain how this diagram represents this question, I just want to recap over what the diagram means. So as you can see here, we have radius, we have our angle. This can also be called the central angle, and we have our arc length. This small a represents the arc length. Okay, so this angle, when you're dealing with arc length, it has to always be in radians. So lucky for us, we are given radians in the question, but if you were given degrees and you're dealing with a question that involves arc length, you have to convert that degrees to radians. Okay, so make sure you do that. And then as I said earlier, we're given radius, and then the arc length is basically the distance on the circumference that is created by this angle here. Okay? So now that I explained that, going back to the actual question, Mark starts at point A and he stops at point B. And it's saying, what's the distance Mark traveled in his car? So as you can see from this diagram, if we find the arc length, we figure out the distance Mark traveled in his car. So all we have to do is find the arc length, and as you learned in the lesson, we can use this formula to solve for the arc length. Okay, so first thing I'm going to do is I'm going to rearrange this formula so that I can solve for the arc length. Okay, so what I'm going to do here is I'm going to multiply both sides by r to get rid of this r. So when you do that, you get r theta is equal to arc length. Okay, and now that you've done that, we have isolated for the arc length, and now we can just plug in our numbers into this side of the equation and solve for the arc length. Okay? Okay, so what I did was I just rewrote this formula down here. So the arc length is equal to the radius times the angle. Okay? We are given radius in the question, 15 meters, and we are given the angle that Mark creates, which is 3 radians. So now we just plug these numbers into the formula and we solve for the arc length. Okay, so when you plug in your numbers into the formula, you get 45 meters. So therefore, what is the distance Mark traveled in his car? Well, Mark traveled 45 meters. Okay, so that's the answer to this question. Okay, so that is the end of the video. This is the answer, but I just want to note, when I said earlier in the video, if you're given the angle in degrees, when you're dealing with arc length or central angle, you have to make sure that the central angle is in radians. So just to recap, if you don't remember how to convert from degrees to radians, you do degrees, so whatever degree you have, so let's say you have 50 degrees, and you multiply that value by pi over 180. So when you do that, you get your answer in radians, and then you would plug that number into this formula to solve. So just wanted to go over that.